Okay, today we're looking at differentiating rational powers. So that just means when we have a fraction as a power, and you still do the same if you look at this rule, you have the power gets times with the number at the front, which would be 1, so there, and there's the fraction, so the fraction times, and then you still minus 1. So let's have a look at this example. If they said, so if we said, here we've got y equals 4x power of 2 over 3. If we were finding dy dx, what we're going to say is it'll be 4 times the power, which is 2 over 3, and then it's the power, you minus 1. So if you multiply this out, you get 8 over 3x. Now, if you think about, we have to think about our fractions here. If you've got 2/3 minus 1, which could be written as 3 over 3, you're going to get negative 1/3. So this is how I end up with x to the power of negative 1/3. Now, if we don't want negative powers, which they often don't, we would just pop that x down the bottom and it would look like that. Or if we don't, this also could be written as 8, because remember, something to a power of 1/3 could also be the cubic root of x. So just in multiple choice, you might have a couple of answers you might have to look for. But either way, if I don't say a positive power, this one's okay to leave it there. Okay, let's do the other example. So dy dx. So we take the power and we multiply it at the front, and then I'd have 1/5 minus 1. And then the next term would be negative 3 times 2, which becomes plus 6, and then I'd minus a power. So we end up with, now remember 1/5 minus 1, we're going to end up with 1/5 x negative 4 over 5/5. And then we've got plus 6x to negative 4. And if they asked us to make that in positive powers, we could say that is 1 over 5x to the power of 4 over 5, and we could say plus 6x to the power of 4, like that. That's if we needed positive powers.